Objectives. In this lesson, we will recognize the property of the median relative to the hypotenuse. We will recognize that a triangle with a median of half its relative side is a right triangle. What you need to know before starting your new chapter. First, a right triangle is a triangle that has a right angle. In a right triangle, the hypotenuse is the side opposite to the right angle and the other two sides are the legs. The angles adjacent to the hypotenuse are complementary. In a right triangle, the orthocenter of a right triangle is its main vertex. As we see here, ABC is a right triangle at C. The point of intersection of the three heights is the main vertex C. A right triangle is called an isosceles right triangle if it has two equal angles or two equal sides. A right triangle is said to be semi-equilateral if the angles adjacent to the hypotenuse are 30 degrees and 60 degrees. As we see here, this is a semi-equilateral triangle. It is a right triangle, but the two adjacent angles to the hypotenuse are 30 and 60 degrees respectively. Objective 1. Recognize that the median relative to the hypotenuse of a right triangle is equal to its half. Consider triangle ABC, right at A, and M is the midpoint of BC. As we see here in the figure, we have triangle ABC, right at A, M is the midpoint of BC. N and P are the respective midpoints of AB and AC. So P is the midpoint of AC, and N is the midpoint of BA. PX and NY are the perpendiculars to AB and AC respectively. Our objective is to show that AM is equal to BC over 2. First, what does AM represent? Here AM in triangle ABC. What does AM represent in triangle ABC? Recall that M is the midpoint of BC. AM represents the median relative to hypotenuse BC. Since M is the midpoint of BC, AM is the median relative to hypotenuse BC. Show that PX and NY intersect at M. First, in triangle ABC we have P is the midpoint of AC, given. PX is parallel to AB. Since PX is perpendicular to AC and AB is perpendicular to AC, so PX is parallel to AB. Two lines perpendicular to the same straight line are parallel. So by midline theorem, PX passes through the midpoint of BC, which is M. N is the midpoint of AB by given. NY is parallel to AC since two lines perpendicular to the same straight line are parallel. We have here, as we said before, in the same way, NY is parallel to AC since NY is perpendicular to AB and AC is also perpendicular to AB, then NY and AC are parallel. N is the midpoint of AB, so by midline theorem, NY passes through the midpoint of BC, which is M. Then we have PX passes through M and NY passes through M. Then PX and NY intersect at M. Show that M is the center of circle M circumscribed about a triangle ABC. How to show that M is the center of the circle circumscribed about a triangle or right triangle ABC? We know that in order to draw any circumscribed circle about any triangle, we have first to draw the perpendicular bisectors of the sides of this triangle. Okay, let's see. We have PX passes through the midpoint of AC and perpendicular to it, so PX is the perpendicular bisector of AC. Also, N is the midpoint, NY passes through the midpoint of AB and perpendicular to it, so NY is the perpendicular bisector of BA. It is enough to draw two perpendicular bisectors to locate the center of the circumscribed circle. M is the point of intersection of two perpendicular bisectors of two sides of triangle ABC, then M is the center of circle M, circumscribed about triangle ABC. Now, deduce that MA is equal to MB and equal to MC. Where is MA, MB, and MC? Let's see. MB, MC, and MA. Deduce that they are equal. How? We have M is the circumscribed circle about triangle ABC. What does MA represent to this circle? It represents the radius because it is issued from the center to the circle. Okay, what does MB represent to the circle? Also a radius. What does MC represent to the circle? Also it is a radius. So MC, MB, and MA are three radii of the same circle, and radii of the same circle are equal. So since MA, MB, and MC are three radii of same circle, then they are equal. What does BC represent in circle M? BC is the diameter of circle M. Deduce that MA is equal to BC over 2. Deduce that the median in right triangle ABC, median MA relative to hypotenuse BC, is equal to half BC. Since MA, MB, and MC are three radii of the same circle, and we proved that they are equal, then MA is equal to half B. MA is a radius of M, and BC is the diameter. Then MA is equal to half BC, since the radius is equal to half the diameter. Conclusion. We conclude that in any right triangle, the median relative to the hypotenuse is equal to half the hypotenuse. Example. Consider this triangle ABC right at A, such that BC is equal to 8 cm and M is the midpoint of BC. We have to find the length of AM. So, ABC is the right triangle at A, M is the midpoint of BC, and BC is of length 8 cm. How to find AM? First, AM is the median relative to hypotenuse BC. ABC is right at A. AM is the median relative to the hypotenuse BC. Then AM is equal to half BC. That is, AM is equal to 8 over 2, which is 4 cm. Objective 2. Recognize that a triangle with a median equal to the half of its relative side is a right triangle. BC is a segment and M is its midpoint. A is a point outside BC such that MA equal MB equal MC. So, A is a point outside BC, is any point outside BC, such that MA equal to MB equal to MC. Our objective is to show that ABC is a right triangle. What does AM represent in triangle ABC? From the given, we have M is the midpoint of BC. So AM is the median relative to BC by definition of midpoint. Deduce that A, B, and C belong to the same circle. Because MA equal MB equal MC, then the points A, B, and C belong to the same circle of center M and radius BC over 2, which means the diameter over 2. M cuts the circle in D. Show that ABDC is a rectangle. First, we have M is the midpoint of BC. Also, M is the midpoint of AD, since the center cuts the diameter of the circle in its midpoint. Then the diagonals AD and BC bisect each other. Then ABDC is a parallelogram. Also, AD and BC are equal, two diameters of the same circle. Then ABDC is a rectangle, by diagonals bisect each other and equal. Deduce that ABC is right at A. Since ABDC is a rectangle, then it has 4 right angles, including angle A. So angle BAC is a right angle, hence ABC is a right triangle at A. Conclusion. We conclude that in any triangle, if a median, one of its medians, is equal to the half of its relative side, then this triangle is a right triangle. ABC is a right triangle at A such that BC is equal to 8 cm and M is the midpoint of BC. We have to find AM. First, what does AM represent in triangle ABC? Since M is the midpoint of BC, then AM is a median. But which median? It is the median relative to the hypotenuse BC. So the rule says in any right triangle, the median relative to the hypotenuse is equal to half of it. Then AM is equal to half BC. So AM is equal to half BC, which is 8/2, 4 cm. Exercise. Draw a segment BC of length 5 cm. R is the midpoint of BC. M is a point outside BC such that MR equal 2.5 cm. What is the nature of triangle MBC, and justify your answer. MR is a median by definition of midpoint. MR is equal to 2.5 cm by given. BC is equal to 5 cm by given. So MR is equal to BC/2. Then MBC is right at M since the median is half the relative side.